Guys, welcome to this week's problem of the week. This week's problem of the week is called Ty's formula. As per usual, I'll run through the program. I'll run through the problem and I'll run through the code, and that's about it. Okay, so first a read through. Have you heard about the mastermind Ty? He's found a way to calculate the area under a glucose curve, given discrete measurement points. He even validated his formula against the approximate technique of counting the number of scores below the graph when printed on graph paper. Can you, just like Ty, reinvent the wheel and calculate the area under a glucose curve? Instead of publishing a paper, you need to implement the algorithm. You need this algorithm in your new app that logs your glucose values that comes from a continuous glucose monitor. You have also figured out the trick of the device. It's not actually continuous, it just samples the glucose value frequently, automatically. Input contains several lines of numbers separated by spaces. The first line contains the integer n, where n is between 2 and 10,000. Following n lines describe samples. Each line contains two numbers, where t is the time and v is the glucose. The glucose value v is within 2 to 23. Okay, and then the time of each sample is the number of milliseconds since the 1st of January 1970. Samples are always given in increasing order by time. Okay, and you want to output the area under the glucose curve in the unit moles per liter times seconds. Okay. All right, let's read through this sample explanation. In sample input 1, there's 3 data points where the area between the t-axis and the curve is formed by 2 trapezoids. First trapezoid has this area, and the second has this area, and you sum it up. Okay, and then here's a nice visual. I'll zoom in here for you guys. But that's a nice visual of basically what we're looking at. Is you're really just looking at taking the area at each interval. So I wouldn't say it's too difficult of a problem, because you basically parse these in and then you figure out how to calculate the area of a trapezoid. Okay, let's look at some of the code. So I start off with the iteration input and I cast it to integer. I do the sorting, so I declare some lists where I can sort the data in, because you need to sort it in once and then calculate it. Well, there is an alternative way. I just think sorting it in initially is the best method. Then I run through this iteration. I do input, I split it, and then I throw them into the lists. And then here I just run a for loop to calculate the area of the trapezoid. So I go back through this range. Note that here I start at 1, and that's because when you calculate the area of the trapezoid, as you see here, you take your current value and the previous value, and then you take the difference there, and then you also take the average of the glucose. So that's why I started at 1, so that I can reference the previous value. I calculate the difference in time. I really just put an absolute value here as like a insurance. I'm pretty sure it's not possible, but I kind of just had it there. And then I append the difference, the area of the trapezoid to the total. Basically what I do is, when you calculate the difference in time, what you're really calculating is the length of this segment on the x-axis, or I guess here it's called the t-axis, but you're calculating the length of that segment. And then I'm taking the average of the glucose levels, which is kind of parallel to what they're doing right here. And then I add that to the total, and then here I print out the total divided by 1,000. All right. Oh yeah, sorry, I forgot where the sample data was. Yeah, but as you can see, this works pretty swimmingly. We'll grab the second pair. And yeah, so that works fine. I know some of the problems will specify that they need to be a particular digit, in which case you need to format the output. Here it's fine because they give you a relative error boundary. So this is fine because it's pretty well within your error. All right, so that's the code for this week. Have a nice weekend.